And welcome back. As we continue our cosmic journey through our solar system, we previously looked at asteroids, but let's go ahead and shift that lens just a little bit to talk about asteroids and their role in planetary defense. So the first thing we have to understand is the concept of Earth approaching asteroids. Asteroids that stray far outside the main belt of the asteroids belt are of interest mostly to astronomers. But asteroids that come inward, especially those that have orbits that come close to or cross the orbit of Earth, are of interest to political leaders, military planners, and indeed everyone alive here on Earth. Now, some of these asteroids briefly become the closest celestial object to us because of how close they actually come. In 2013, a small asteroid hit our planet, streaking across the sky over Russia and exploding with the energy of a nuclear bomb. The impactor was a stony object of only about 20 meters in diameter, exploding about 30 kilometers high with an energy of about 500 kilotons. Now, nobody was hurt by the blast itself, because remember, it exploded 30 kilometers high. Although the blast wave from this exploding object blew out windows, and it caused about 1,500 people to seek medical attention, because naturally, what happens in human nature is like, oh, look at this bright, shiny thing coming off the sky. It's really cool. It's interesting to see. Everybody, of course, wanted to see it, and when the shockwave hit, the glass came out and shattered and injured a lot of people who were standing near windows. Now, a much larger atmospheric explosion actually took place in Russia in 1908, caused by an asteroid about 60 meters in diameter, releasing energy of about 10 megatons, as large as the most powerful nuclear weapons of today. Now, very fortunate that the area that was directly affected on the Tunguska River in Siberia was unpopulated, and therefore nobody was killed. However, the area of forest that was destroyed by the blast was very large, equal to the size of a major city. So you can only imagine if something that big, with that same trajectory and everything like that, came and hit us today, the amount of devastation, destruction that it would inflict. So let's go ahead and use this to kind of discuss the orbits of the asteroids once again. Together with any comet that come close to a planet, such asteroids are collectively known as near-Earth objects, or NEOs. Now, astronomers have urged that the first step in protecting Earth from future impacts by NEOs must be to learn what potential impactors are out there. In 1998, NASA began the Space Guard survey with the goal to discover and track 90% of Earth-approaching asteroids greater than 1 kilometer in diameter. At 1 kilometer or larger, the impact would threaten the survival of our civilization. Now, notice we can still have quite large things still hit because, for example, as we saw with the 60-meter one, when it hit Tunguska, that would have impacted a major city. That's still a lot of destruction, devastation that could happen. But at 1 kilometer larger, we're starting to get into danger zone. So, the first thing we want to probably do in the event of an asteroid coming our way is look at deflecting an impact. One of the reasons scientists are interested in the composition and interior structure of NEAs is that humans will probably need to defend themselves against an asteroid impact someday. If we ever found one of these asteroids on a collision course with us, we would need to deflect it so it would miss Earth. I know, a lot of times we want to go the Hollywood approach and say, let's just blow it up. But that doesn't necessarily stop the impact of that asteroid. All you might have done now is simply just taken that giant asteroid and now just made it into a bunch of smaller asteroids that are now come and rain down upon you. So the most straightforward way to deal with an asteroid of this size would be to deflect it. It would be, you can do several ways. Just crash spacecraft into it, slow it down, speed it up, slightly change its orbital period. And if this were done several years before the predicted collision, the asteroid would miss the planet entirely, making the impact the only natural hazard we could eliminate completely by the application of technology. It's like if we know it's coming, we can apply some thrusters to it, we can push it away. We have a couple options. Alternatively, such a deflection could also be done by exploding a nuclear bomb near the asteroid to nudge the course. In other words, you have such a large impact that maybe you can give it a forceful push. Although the use of nuclear explosives in space raises other concerns, because now we're just setting nukes off in space.